Let's talk about subsets. So set A is a subset of set B if every element in set A is also an element of set B. Okay, we have notation for this. We write A is a subset of B. Again, being really clever math people, if A is not a subset of B, we can write A subset symbol with a line through it, B. So that's A is not a subset of B. Couple things here. When you're thinking about subsets, you want to be thinking about less than or equal to. Since I have this line underneath, I want that to imply less than or equal to. So in fact, if sets are equal, then they're subsets of each other. We're not going to use any symbols that face the other direction. We're not going to use this thing or this guy to mean anything. Those we do not want. So we're just going to use this symbol to mean is a subset of, meaning that everything in the first set is also in the second set. So let's look at some examples here. I want to determine if I should put the subset symbol or not a subset symbol between these sets. I have the set A that it has the elements 1, 2, 3, 4, 5. I have the set B that has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here, everything in set A is in set B, which means that A is a subset of B. Okay, nice. Everything in A is in B. A is a subset of B. Next up, I've got the set M. M is the set of all X such that X is a letter in Mississippi. So that's M, I, S, P in roster form. N is the set of all X such that X is a letter in Michigan. That's M, I, C, H, I again, G, A, N. So there's the set. Oh, jumped around here a little bit. There's the set N. So is M a subset of N? Well, when I look, M is in there, I is in there, but when I go looking for S, I don't find it. That means that everything that's in M is not in N, and that means that M is not a subset of N, because there's something in M that is not in N. All right, how about here? I've got the set P that has 2, 3, 5, 7, and then I have the set O, which is 1, 3, 5, 7, 9, and so on. I can see that this set O goes on forever, but again, I have to remember no one's trying to trick me by writing this set down this way. This set continues in the way that I think it should, with 11, 13, 15, 17, and so on. That means that 2 is not going to be found in that set. So since 2 is in P, but it's not in O, P is not a subset of O. Okay, now I have the empty set and the set G that has red, green, and blue in it. So when I look at that, I can say, well, the empty set, remember, is this set that has nothing in it. Is there anything in the empty set that's not in G? No. In fact, everything in the empty set is in G because there's nothing in the empty set. So the empty set is a subset of G. All right. Here I've got a set O. It's the numbers 1, 3, 5, 7, 9, and so on. And then I have the set N. Remember, this is the natural numbers, 1, 2, 3, 4, and so on. So I want to know, is the set O a subset of the set N? Well, 1 is in there, 3 is in there, 5 is in there, 7 is going to be in there, 9 is going to be in there. So in fact, everything in this set O is going to be in N, so O is a subset of the natural numbers, right? Everything in O is in N. Okay, last one. Here I've got a set A that's 2, 3, 4, and I've got a set B that's 2, 3, 4. When I go to look, is everything in set A in set B? Well, I can see that 2 is in there. I can see that 3 is in there. I can see that 4 is in there. So in fact, everything in A is in B, so A is a subset of B. Remember, I want you to think about that subset symbol as being less than or equal to, and here's one of those cases where they're equal, so in fact, it is a subset.